19 in this question number 1 2 3 completed, 3 questions. Fourth one is okay, the enthalpy of hydrogenation of cyclohexane is given, the resonance energy of benzene is given, its enthalpy of hydrogenation would be okay. Here question number 4 is question number 4, given hydrogenation of cyclohexane. Hydrogenation means addition of hydrogen to the corresponding alkenes. It is a cyclohexane, gives cyclohexane. This is so this hydration energy delta H is equals to minus 119.5 kilojoules given. If the resonance energy of benzene is given, then its enthalpy of hydrogenation energy would be in that. Now here this is the benzene. To this 3 moles of hydrogen gas is added, we'll get here cyclohexane. Here its formula is C6 and H6, but here cyclohexane formula is C6 and H12. Now this value is equals to how much? Question mark. Benzene to the cyclohexane. Now here the 1 mole of double bond is converted into a single bond. 1 mole of hydrogen molecule required, this much amount of energy is released. But here double bonds 3 are there. 1, 2, 3. 3 moles of hydrogen required molecule. For 1 mole double bond to single bond, that much. Now here are 3 moles required, that's why first it is multiply with 3. This is. Now we'll get here value, multiply this, but it is not a final value because it has resonance energy. Benzene has resonance energy. That resonance energy given, resonance energy is of benzene given here 150 minus 150.4 kilojoules per mole amount of energy is there. Now by using these, if you want hydrogenation energy of this from the liberated amount of energy, remove this resonance energy, will get the hydrogenation of benzene to the cyclohexane. So here this value minus this value. Now that is this is 5. This is again this is 3, 5, and this is 3 minus 358 point. From this, remove your resonance energy RE. Now it is 358.5 minus 150 value, given value is 4. This is so nearly here we'll get 150.4. This is 1. This is 8, 0, 2. That is 208.1. That is third option, C. So our problem is, observe once again, 1 mole of cyclohexene is converted into cyclohexane. 1 double bond, 1 mole. But here the three double bonds are there, it also undergoes a resonance due to the delocalized pi electrons. It undergoes some amount of energy that is called a resonance energy, RE. That resonance energy is minus 150.4 kilojoules per mole given. Resonance energy means bonds here. Here double bond is there, here no double bond. Due to the delocalized pi electrons, it undergoes certain amount of energy that is called RE, resonance energy of benzene, experimentally determined. 1 mole of benzene is converted into cyclohexane, 3 moles required. 1 mole of hydrogen, that much, 3 moles means multiply. This is the complete, but here it undergoes some resonance energy. From total value, subtract that, we'll get the hydration of benzene. Okay, clear. Next, question number 5. Consider the following reaction. 4 reactions given. There are hydrogen ion, hydroxyl ion, water. Second one is H2 plus half O2 gives H2O. Third one is CO2 plus H2 gives CO plus H2O. And fourth one is H2C2 plus 5 by 2 O2 gives 2 CO2 plus H2O given values. The enthalpy of formation of water. Once we can observe all the 4 examples, water formation is there. Water is there. But here question number 5 in this enthalpy of formation, standard enthalpy of formation of water, we want H2O. In all the 4 cases, water formed from reactants to products. But the original definition, according to the statement of formation, 1 mole of water is formed, H2O is formed, 1 mole liquid is formed from its constituent elements, standard elements. Here, constituent standard elements means water is formed from H2 gas plus of H2 gas. This is the correct equation for formation of water according to definition. Standard enthalpy of formation of water is the amount of heat liberated or absorbed plus or minus Q when 1 mole of water or any compound is formed from its constituent elements, means H2 and of O2. These are the elements. This is present in second option. That's why that is the correct one. In the remaining 3 options, water is formed, but they are not from constituent atoms. Their ions are from molecule. See the first one, your H plus aqueous plus OH minus aqueous. Like H2O is formed. This water is formed from its ions, not from its elements. That's why definition cannot accept. That's why it is wrong. Also, third, fourth examples also, water is formed. That water is not from its constituent elements. They are from compounds. That's why option number given equation 1, 3, 4 are the examples for enthalpy of reaction, not formation. Formation is always formed from its constituent elements. That's why answer is given answer is D option is correct. D means in enthalpy of formation of water, in second one, delta H value is minus x2 kilojoules per mole given. That's why answer is present in D. That's why minus x2 is the correct one. Next, question number 6, 7 explained to you already while explaining bond energies. Question number 8. In question number 8, one chemical reaction given, that is PCl5 gas gives rise PCl3 gas plus Cl2 gas. By using these, here 1 mole, here 1 mole, here 1 mole, N1 gas is equals to 1, N2 gas is equals to 1 plus 1, 2. Here delta N is equals to N2 minus N1, that is 2 minus 1, that is equals to 1, that is a positive value. Delta N value is positive, then delta H is greater than delta U. Also here, instead of using this, here S1 equal to 1, S2 is equals to 2. S1, S2 means entropies in initial and final states. Okay. So here delta S is equals to S2 minus S1, that is 2 minus 1, that is positive value 1. So by using this, given statement is, in which of the following conditions are correct? So here greater than, if it is delta N is equals to 0 or delta V is equals to 0, delta H is equals to delta U, both are equal. But here greater, that's why delta H is greater than 0 and delta S also greater than 0. Because according to delta H is equals to delta U plus delta N RT. Clear? Now here this value is positive. That's why delta U plus 1 into RT. To delta U something is added. That's why total value is more. That's why this value is more. That's why here delta H is greater than this or greater than 0. That's why answer is D option. Delta H is greater and delta S also greater than 0. Next, ninth question already explained. Anyhow, which of the following are not a state functions? State function means which depends only on initial and final state, but not on path followed by the system. That's why here first question number 9, delta U is equals to Q plus W. First one given like. Second one is Q given. Q. Third one is W given. W. And fourth one is H minus TS. Among these, not a state functions. Here, delta U is the sum of heat and work. It depends on initial and final state, U2 minus U1. It is a state function. Now, here, G is equals to delta H minus T delta S. Delta G, nothing but G2 minus G1. It is also a state function. Individually, work and heat are not a state functions. These are the path functions. Clear? So answer is B. B contains second and third. Next, question number 11. The values of delta H and delta S for the reaction, one reaction given. That reaction is question number 10. That reaction is C plus graphite given here. That is solid plus O2 gas. It gives CO2 gas. Now for this delta H value and delta S values given. This is this reaction is spontaneous yet. Spontaneous means delta G is negative. This value given, that is 170 kilojoules. This is 170 joules per Kelvin. Now by using these, Here n1 is equals to 1, n2 is equals to 1, delta n is equals to 0. If we'll ask delta h and delta u. By using this, delta G is equals to delta H minus T delta S. The process is at equilibrium. That's why delta H is equals to T delta S. T is equals to delta H by delta S. Formula is there. This is combustion reaction because this value given here 170 kilo means 10 cube joules. And it is 170 joules per Kelvin. Joule cancel. 170 cancel. 1000 kelvins. Okay. Per Kelvin, denominator to the numerator, that is Kelvin, that is the temperature units. So answer is 1100 is there, that is nearly 1000 kelvins. Next, question number 11 explained already while explaining bond energies. Next, question number 12. In question number 12, for an endothermic reaction, energy of activation is EA. And enthalpy of reaction is delta H. Both of these in kilojoules. Minimum value of EA will be, energy of activation will be. Yesterday while explaining exothermic and endothermic reaction, one reaction graphical explanation given to you. This is the potential energy. Reactants, now it is like this. This is one set. This is the enthalpy of the reactants, enthalpy of products. This is the activation energy EA for forward reaction. Now delta H is equals to HP minus HR. Your HP is less than HR. Heat is reactant heat is more. Your product is less. That's why this is the graph for exothermic reaction. But here question is endothermic reaction given. That's why endothermic reaction we can write the graph is like this. Now this is enthalpy of reactants, enthalpy of products. Now this is the difference between enthalpy of reactants and products, HP minus HR. Now the value of heat product, this is products and this is the reactants. Here the enthalpy of the products is more than compared to the reactant. That's why this value is positive. That is endothermic reaction. So question is not based on this, based on this. Yesterday explained. For endothermic reaction now, value will be more than this given. This value is here to here. This is from reactants to products to excite like this here to here. This is the activation energy. This activation energies will be compared to this what? Compared to this activation energy will be greater. That's why EA is greater than delta H for endothermic reaction. If it is exothermic reaction, here EA value is less than delta H. This is for exothermic reaction. Both are very, very important. Now, right now, for endothermic reaction graph is this. Question number 12. Next, question number 13. Standard entropy is given. X2, Y2, XY3 are given. For the reaction or reaction given, then delta H value given. To be at equilibrium, the temperature would be, this model already covered in question number, previous question number 8. Question number, this is 10 given, same model, but indirectly given here. That indirect question is, question number 13, your x2 plus y2, 1 by 2 x2 plus 3 by 2 x2 gives your xy3. It is a guess, it is also a guess, it is also a guess. Delta H value given, that is minus 30 kilojoules. But here entropy of x2 given, that is 60, and here y2 given 40, and this value given 50. We want delta S. Because to calculate the temperature, formula is delta H by delta S. This is the formula to calculate the temperature. We want temperature. To calculate the temperature, we want enthalpy and entropy change. In previous problem, previous year, direct two values given, T calculated, but here indirectly delta S. So for this delta S, entropy of products minus entropy of reactants, we know formula. But here value is only x2 given, not 1 by 2 x2. y2 given, not 3 by 2 y2. That's why your direct 1 mole is there, it is a product. By using this, your product is 1 into 50 minus of 1 by 2 into 60 plus 3 by 2 into 40. This is the enthalpy of products minus sum of the enthalpy of reactants. Now this is 50 minus of your 30 and your 26. Finally, here the 30 plus 60, that is 50 minus 90, that is minus 40 delta S value. That is in now minus okay. So here 3 to the 60 and here 30, 90 minus 40. This is in joules per Kelvin it is. Now we know this value. This is, we can write minus 30 into 1000 joules. Now by using this, here minus 30 into 1000 divided by 40 joules per Kelvin. Here joule get cancelled, and this is here 3000 divided by 4. We'll get the answer. That is 750. Okay. Next. Question number 11 in mains given, that is list 1 and list 2. By using previous complete derivations. Question number 14, your mathematical expression based, your Kp is greater than Qc or Q. This is the reaction coefficient. This is greater. To identify this, we want delta G is equals to minus 2.303 nRT log Kp. This formula we want. Now here Kp is greater. Kp is greater means positive value. Positive value means it is a positive into negative, negative. Then delta G is equals to negative. Negative means it is a spontaneous process. That's why, yeah, first for A, we can take a fourth one in list 2, that is spontaneous. Delta G is less than RT. If it is delta G is less than this value, means it is a negative value, that is a non-spontaneous. Negative into, first one is negative into that negative, positive will get it. Non-spontaneous. Kp is equals to Q, reaction coefficient and equilibrium constant, both are equilibrium. That's what is the equilibrium process. Then fourth one is T is greater than delta H by delta S. here delta G is equals to delta H minus T delta S. It is greater. Greater is nothing but high temperature. At a high temperature, this value is high. So value is very high means negative value will get it. Negative value is nothing but it is a spontaneous process. Okay? And compared to this, your endothermic process, and this value is high temperature, negative value is small. Total this value is final value negative will get it. That is a spontaneous process. Clear. Question number 15 explained. Already there is a mistake in option. That is 3 moles of ideal gas expands spontaneously into vacuum. Vacuum means there is no work. Work is 0. Question number 16. For vaporization of water at 1 atmospheric pressure, values of delta H and delta S given. The temperature when Gibbs energy change for this transformation will be 0. Means the process is at equilibrium. Transformation equal to 0 means the process is at equilibrium. Then calculate the temperature. Question number 16. Here delta G is equals to delta H minus T delta S. And one vaporization of water given. Vaporization of water means H2O liquid is converted into H2O vapors. This is the enthalpy of vaporization, that value given. And here it is a gas and it is a liquid. By using this delta S, we can calculate already given values. But the process is at equilibrium. Process carried out in a closed vessel. For this delta G is equals to 0. By using this delta H minus T delta S. T delta S is equals to delta H. Clear? Now T is equals to delta H by delta S. Apply this formula. Values given here, delta H value is 40.63 kilojoules divided by 108.8 joules. Now this value is multiplied with 1000 into 1000 divided by joule. It is 108.8 into joules per Kelvin. This and this get cancelled. Now cancel it, you will get the answer in Kelvins. That answer is 373.4. Question number 17. This is very, very important. Question number 17 model is question number 17 model. 2 reactions given. The FeO plus CO gives Fe plus CO2, that delta H is equals to minus 16.5 kilojoules. Then second reaction is Fe2O3 plus CO gives 2 FeO plus CO2. Here delta H is equals to given, that is okay, should calculate so this value is how much? Before that, one chemical reaction given, that is Fe2O3 plus 3CO gives like 2 Fe plus 3CO2. Then delta H is equals to given, that is minus 26.8. These are the 2 reactions given. Then what is the value of this reaction? Okay, so by using this, your equation 2 is this equation 2 is reversed. There are the equations 1 and 2 reactions. This is according to the Laplace-Levasseur law, first law of thermochemistry. According to first law of thermochemistry, when the amount of heat is liberated or absorbed, when the reaction is reversed, its magnitude is the same, but a sign differs. So to get this required reaction, so equation 1 is as it is, better you write Fe2O3, 3CO gives 2Fe plus 3CO2, value also same, minus 26.8 kilojoules. This is equation 1. So equation 2 is reverse. Means here the CO2 plus Fe gives FeO plus CO, delta H is equals to value reverse, that is plus 16.5 kilojoules. See here, one Fe is there, here two Fe's are there, one Fe balance. Sorry, reverse and multiply. Reverse and multiply with 2. This value also multiply with 2. Here 2 CO2, 2 Fe, 2 FeO, and 2 CO. 2 Fe, 2 Fe get cancelled. Here out of 2 CO2 and 3 CO2, 1 CO2 get cancelled. Here CO3, here 2 are there, get cancelled. Finally, we'll get Fe2O3 plus CO gives 2 FeO plus CO2. Now, by adding equation 1 and 2, these two are equal. That's why this value also delta H1 plus delta H2. That is minus 26.8 plus 33. This is. Now, answer is positive value, we'll get it. So, answer is here plus 6.2 kilojoules. It is an endothermic reaction, plus 6.2 near answer kilojoules will get it. Okay. Now, answer is for this D option. So, the question number 18, if the enthalpy change for the transition of liquid water to steam at particular temperature given, the change in entropy for the process would be same model like question number 18. In this question number 18, your water liquid to a water vapor, it is a equilibrium process, delta G is equals to 0. Delta H value given, that value is 30 kilojoules given. Temperature is 0 degrees given, that is 273 kelvins. Then calculate delta S. Same formula, that is T delta S is equals to delta H. We want this, that's why now delta S is equals to delta H by T, will get it. That is 30 kilojoules means instead of joules, we can write 30 into 1000 joules divided by 273 kelvins. So change in entropy units will get it. That is joules per Kelvin answer. So answer is D option. Next. Question number 19. Question number 19. Here 4 hydrogen atoms in gaseous state converted into 2 H2 molecules. Their value given, that is minus 869.6 kilojoules per mole. The dissociation energy of H bond H is how much? Now, dissociation means compulsory reverse required. Reverse this reaction. 2 into H2 gives 4H. This is value also reverse, that is plus 869.6 kilojoules. according to Laplace-Levasseur law, first law of thermochemistry. Now here the 2 into H bond H is equals to 4 H atoms. To break this, how much amount of heat required, that is. Okay. Now here for 2 moles this much amount of heat is required. But asked question is only 1 mole. So 2 moles of H bond H to break that your 869.6 kilojoules required. For 1 mole of H bond H, how much? That is 869.6 into 1 divided by 2, answer 50%. That answer is 434.8 kilojoules. Clear. Then question number 20, direct statements theorem, direct processes. Which of the following is correct option for a free expansion? Clearly given complete information about thermodynamical processes. In free expansion, there is no change in volume, there is no work done. That's why third option, Q is equals to 0, delta T is equals to 0, work done W is equals to 0. Next, question number 21. Consider the following processes. Here are 3 processes given. Question number 21, that is of A gives B. Now value is delta H value is plus 150. Now here the 3, B gives 2C plus D. Also this is delta H is equals to minus 125. E plus A gives 2D, then delta H is equals to plus 350 kilojoules. By using all these, required reaction RR is B plus D gives E plus 2C. In that case, delta H is equals to how much? So this is in thermochemistry, by using enthalpies of reaction, formation, combustion, by using all the reactions. This is the required reaction. By using these 3, just derive this, automatically will get the answer. First, this reaction, I'll take A gives 2B, means it is multiply with the 2. This delta H value also multiply with 2. That is plus 300 kilojoules according to this. So by using, to get this answer, here we want same this side, reactant side B as it is B, okay. And here we want D this side, here D is this side, and E is this side we want. That's why just by some changes, reversing some reactions, will get it this. See here by reversing equation 3, same as equation 1, that is A plus A gives to B. Now delta H multiplied, that's why 300 kilojoules. Because half mole is 150. So multiply with the 2 means get cancelled. Then here 2B value is this. Okay. Then same equation 2 also, that is 3B gives 2C plus D, delta H is equals to minus 120 kilojoules per mole. Reverse equation 3, that is 2D gives E plus A. Now by reversing this value also, value same, its a sign reverse changed based on now first law of thermochemistry and second law of thermochemistry, Hess law and the heat of summation methods. By adding all these, here 3B and here 2B, 1B is balanced. and your A and A get cancelled. Your D is 1, your 1D get cancelled. Finally, your balance is B plus D gives E plus 2C. So our required reaction is obtained. That's why just add all these 300 minus 125 minus 350. Now answer is minus higher value is this 300 minus 475. Higher value is minus 175 kilojoules. Answer. Okay. Next. Question number 22. In which of the following reactions standard entropy change delta S is positive and Gibbs free energy change decrease sharply with increasing temperature? Now to explain this, yesterday about delta G, delta H, delta S relation Gibbs free energy change given. There question number 22. Delta G is equals to delta H minus T delta S relation is there, or under standard conditions we can take a like. Their standard free energy change is positive. This value is positive given. Positive means delta S naught value is S2 minus S1. That is this product value is greater than this. That's why here will get positive value. Here S2 is greater than S1. So in which of the following reaction your delta S value becomes positive? That's all reaction. Now first reaction, so the first reaction are the C plus of O2 gas gives your CO also a gas, your 1 mole, your half mole, your 1 mole, here it is reactant, it is product. Delta S is equals to S2 minus S1. S2 value is 1 mole, S1 value is half mole. That's why 2 minus 1 by 2, that is 1 by 2, that is 0.5, that is a positive value. First option is this. So the second option, like CO plus half O2 gives CO, also a gas. It is a gas, it is a gas. For this delta S is equals to 1 minus of 1 plus 1 by 2. That is 1 minus 3 by 2, that is 2 minus 3 by 2, that is minus 1 by 2, that is minus 0.5. It is a negative value. So in this expression, to get this positive value, 4 options created. Among 4 options, which one has a positive value? Means first one has the positive value. That's all. By using state of the reactants and products, we can easily determine delta S value. Next. 23rd, enthalpy of fusion of water. We know already fusion means your water, solid water is converted into liquid. In that case, molar enthalpy change for melting of ice at 100 degrees Celsius is. This is also directly explained in previous number of years given. Your H2O solid is converted into H2O liquid. This is called a enthalpy of fusion. This value given, enthalpy of fusion given, that value is 1.435 kilocalories given, not joules. Now here the temperature value given, the temperature value is 0 degrees Celsius, that is 273 kelvins. Now by using these, here calculate molar entropy change. Molar entropy change means delta S value is equals to how much? So based on this, we can calculate directly. We can use formula. Here T delta S is equals to delta H, that is delta S is equals to delta H by T, that is 1.435 into 1000 divided by 273. Here delta S value also will get in calories. Okay, calculate. Answer is first one. Next, 24. Standard enthalpy of vaporization of water given, then internal energy of vaporization of water is. Question number 24. Your water liquid vaporizes to water gas. It is a equilibrium process. Your N1 is equals to 0, N2 is equals to 1 mole. It is a liquid, it is a gas. For this delta H naught vaporization value given, that is 40.66 kilojoules. Temperature also given, that is temperature T is equals to 100 degrees Celsius or 373 kelvins. Then for this reaction, delta U is equals to how much? Change in internal energy is how much? I'll give the direct formula. Delta H is equals to delta U plus delta N RT. R is constant, that R value is equals to 8.314 joules per Kelvin per mole. It is in joules, but it is in kilojoules. That's why it is multiply with 1000. Now that is your 40,660 joules. By using this 40,660 is equals to delta U plus this value delta N value. By using this, we'll get delta N is equals to 1 minus 0, that is 1 into R value 8.314 into 373 kelvins. Calculate it, answer will get it. Multiply this, subtract from here, we'll get the delta U. Okay, so answer is A. Next, 26. Sorry, 25 missed here, number 26. A reaction having equal energies of activation of forward and backward reaction, reverse reactions. Already about this reaction for exothermic and endothermic reaction given, that is potential energy, your enthalpy of reactants and products. Now, if you can take like one is for exothermic, another one is for endothermic reaction. But here given enthalpy of forward reaction and backward reaction, both are equal. Here it is exo and endothermic reaction, but here both forward and backward reaction, both are equal. There is no change. Here there is a delta H value. Here there is a delta H value, positive or negative value, but here there is no such change. That's why delta H is equals to 0 for a reversible forward and backward reactions. Next, 27. Which of the following statement is correct for the spontaneous while adsorption of gas? Question number 27. This is the solid material in surface chemistry in a closed vessel. This is adsorbent. This is the bend. Molecules are randomly moved and slowly deposited, accumulated on the surface of this solid substance. Now this is at final state S2. This is the initial state S1. Here in initial state, molecules randomly moves in all possible directions. Randomly moves in all possible directions means entropy is more. S1 is greater than S2. By using this is formula, this value is less than compared to this. That's why here we'll get the negative value. delta S is negative. Means while adsorbing the molecule on solid substance, entropy what happens? Decreases. Entropy decreases. Then here delta H and delta S temperature relation is there. That is delta G is equals to delta H minus T delta S. Now here entropy change decreases, initially enthalpy increase, amount of heat liberates. At certain temperature, they are in equilibrium position. Equilibrium means two processes are there here, physical adsorption and chemical adsorption in surface chemistry. Based on that, there is a variation. That's why answer is delta S is a negative, therefore delta H should be highly negative. Then only it is a spontaneous process. Next, question number 28. For a reaction, delta U given, delta S given, hence delta G is. So there is one interlink concept here. Just I'll give the guidelines, better do the homework. Time is only 5 minutes time remaining. Just for all questions, I give the guidelines. Just better you calculate remaining all 4 or 5 important problems. Okay. In question number 28, your delta U value given, that is 20 calories per Kelvin. Sorry, kilocalories. 2.1 kilocalories, and delta S is equals to 20 calories per Kelvin. Temperature is given 300, then delta H is like delta G is question mark. We want this. So to calculate this, we want delta G is equals to delta H minus T delta S. This value we know, but we don't know this value. So to calculate this, there is a formula delta H is equals to delta U plus delta N RT. This is constant, given value 300 kelvins. This is constant. This is value according to the reaction, one reaction given. That reaction is your X2O4 is a gas, gives 2XO2 gas. By using this, delta N is equals to 2 minus 1, that is equals to 1. Delta N value is equals to 1, this value we know, R value, this value we know. And the delta U value given, easy to calculate. This value substitute here, we'll get the answer. Okay. The next, 29. Heat of combustion of carbon to carbon dioxide given. Heat released upon formation of that much amount of carbon dioxide from carbon and oxygen is. So are they based on mass-mass stoichiometric relation. Question number 29. C plus O2 gives CO2. Liberated value is minus 393.5 kilojoules. Our relation is carbon dioxide delta H value given. Here 1 mole. 1 mole of CO2 means 44 grams of CO2. Liberated value is minus 393.5. But the question is for 35.2 grams of carbon dioxide produced, then how much amount of it is liberated? Cross multiply this. That is minus 393.5 into 35.2 divided by 44. Then we'll get the answer. Calculate it. Question number 30, very, very important. It's not given to you. Consider the following liquid vapor equilibrium. One liquid vapor equilibrium given. Which of the following relation is correct? This is question number 30, very, very important. It was introduced for liquid and vapor. There is a good relation by Clapeyron reaction. That is log P2 by P1 direct relation derivation. I'll give direct statement. Delta H vaporization divided by 2.303 R into T2 minus T1 by T1 into T2. This is just like in a chemical kinetics equilibrium constant, two different temperatures or two different rate constant expression. This is converted into a logarithmic form base E, then we'll get like this: d by dt of ln P is equals to delta H evaporation divided by RT square. Derivation if you want, tomorrow I'll continue. Then 31. The correct mathematical thermodynamic condition for spontaneous explained clearly. Table created. Question number 32. Yesterday derivation given. Change in entropy isothermally. Question number 32. Answer is B. 33 explained starting itself while explaining our work done. And 34 same model based on Gibbs free energy change. Then 35 explained already based on bond energies. Then 36 already explained while explaining mechanical work done. Last one question is not mentioned here in this. That last question is 2019 only. In our material not type, missed one question. Please note down that last question. That is 2019 Neet question only from thermodynamics. In which case change in entropy delta S is negative? Other question. Note down in our material. Option 1 is evaporation of water, first option. Second one is expansion of gas at a constant temperature. Third option is sublimation of a solid to gas. And fourth one is 2H atoms gas gives here the 1H2 gas. So for this answer is this. So here the delta S is negative means for this delta S is equals to S2 minus S1. If S2 is less than S1 or SP is less than SR, reactant number of gaseous moles are more than compared to products, then delta S is equals to negative. See here for this, your 1 mole is there. Your gas 2 moles are there. S1 is 2, S2 is equals to 1. Delta S is equals to S2 minus S1, that is 1 minus 2, that is minus 1, it is a negative. Whereas in this case, H2O liquid gives your H2O gas. Your S2 is 1, S1 is equals to 0 because it is a liquid. That's why delta S is equals to 1 minus 0, 1, that is a positive value. Similarly, expansion of gas also, S2 is greater than S1. And sublimation of gas, solid to gas also, S2 is greater than S1. In all the three cases, delta S is positive. But in this case, your 1 mole and your 2 moles are there. Delta S is negative. Very, very important. Okay. So tomorrow, all models covered previous years. Tomorrow I'll start new lesson. From inorganic part I will take. Physical part 1 is completed. Tomorrow I'll start inorganic chemical bonding. Better today read some synopsis about chemical bonding and its molecular structure. Okay. Thank you. Take care.